Welcome, Chemistry 1B, Unit 4, Video Example 5. In this example, we're going to calculate vapor pressure using Raoult's law. So in this case, we have glycerine. It's a non-volatile, non-electrolyte. Okay, non-volatile means it's not volatile, it doesn't vaporize, and a non-electrolyte means it doesn't dissociate in water. This material has a density of 1.26 grams per milliliter at 25 degrees C. We want to calculate the vapor pressure at 25 degrees of a solution made by adding 50 ml of glycerine to 500 ml of water. And the vapor pressure of pure water at 25 degrees is given as 23.8 torr. Now remember the pressure units that you dealt with when you did gas laws? Well, we can use them here. All right, so in order to solve this problem, we're going to use Raoult's law, which is displayed on the slide. So it says that the vapor pressure of the solution is equal to the mole fraction of the solvent multiplied by the vapor pressure of the pure solvent. All right, so we have this, okay, but we don't have this. We need to find that. Okay, so that's the first thing we need to do. We need to find the mole fraction of the solvent. And in order to find the mole fraction of the solvent, we need to determine the number of moles of glycerine and the number of moles of water. All right, so let's do that. So the moles of glycerine, we're given the volume. Okay, so we've got the volume of glycerine, which is here, 50 milliliters. We're given a density so that we can convert it into mass. Okay, and once we have the mass, we can then use the molar mass to find the number of moles. So this is the molar mass. And you see that the units cancel as we need them, and we work out that the number of moles of glycerine is 0.684 moles. Okay, in order to determine the number of moles of water, we do exactly the same thing. Now we know we have to assume the density. We know the density of water, pure water, is 1 gram per milliliter. So we can work out in 500 moles of water, how many moles of water do we have? So we take the volume of water, we multiply it by the density of water, and then we multiply by the molar mass of water in this form, and we end up with the number of moles of water. All right, now the mole fraction we can calculate at this point here. And we know that we have 27.75, hold on a minute, the mole fraction of water, yes, so is the fraction of the solvent that we need to determine. Yes, okay, remember this is not correct. This should be for water. Okay, so we want this for the solvent. Okay, so we take the number of moles of water and we divide it by the total number of moles of both components. So that is the moles of water plus the number of moles of glycerine, and we end up with a fraction. Okay, remember this is a fraction, so there's no units. And we see that we've got 0.76. Actually, it works out to 0.9759. And if we work it out with the correct number of significant figures, it becomes 0.976. And then we can use Raoult's law in this form, where it says that the vapor pressure of the solution is equal to the mole fraction of the solvent multiplied by the vapor pressure of the pure solvent. And we see that when we work that out, the value that we get is lower than the value of the pure material, which is what we expect. Remember the theory that we've dealt with in this course so far is that when we add a non-volatile solute, a non-electrolyte solute to water, we lower the vapor pressure.